you have a half and you have a quarter. Is there another way that you might be able to say that? And I left and I came back and they said, well, a half and a quarter, that's like money. I looked on the number line, it's a 75, a half and a quarter, that makes 75 cents.
Oh, so you have mentioned half and quarter?
Yeah, it's just benchmark, landmark numbers. So she came up and she's exactly right. This is 1.75.
Right.
Right.
Yeah, that was
Well,
good.
what was fascinating to me is that they were making connections with two things. There were several kids who made connections with money, and there were many kids who referred to their fraction kit. What got interesting was where the confusion lies within the fraction kit, because the two children I was working with here and then one of the boys that was sitting over there, the whole is really the elusive piece, because they're pulling out quarters from their fraction kit, laying the quarter of the brownie next to it, and they're not clear, well this is a quarter and this is a quarter, and then putting the whole brownie on top of the quarter and calling the quarter of the brownie a 16th. So there's like this murky time, this disequilibrium that's going on around, well, why is this a quarter and this well, what would you call this other thing? They're not necessarily relating to the whole. What is the whole? And with a lot of questioning and conversation, they can get back to that place. Even Cariana, as she crossed it out here, but I sat with her and she showed me, I figured it out, she said. She had a whole brownie, a whole brownie, a whole brownie, a half brownie, half brownie, half. She cuts the 7th brownie into 4 parts and calls each part 1/16, and then decided that everybody got 4/16. Haven't
Which
a
is a
clue
quarter.
where the 4/16 came from, but when we talked about that division of the brownie, I said, well, what did you divide into parts? And she said, a brownie. I said, how many parts? She said, 4. I said, well, what would you call one of those parts? 1/4. So she goes, oh, and she crossed out the 16 and made it a 4th. I'm not sure where the 4/16 came from, but that's an interesting
Right.
shift.
Like she
She's
wanted
the
to
one
call
who
it a
told you,
7th.
right? She's the one who
Right.
said it was a 7th, and that's not so atypical. That's why when we were meeting earlier, I said, you know, some kids might say, well, we cut it into 7 parts, or that's not. It didn't happen in here, which is actually a very good sign.
Well, she's been working on, that's been happening with the geo boards when they cut an area of 24 into thirds and they're calling those eighths because there's an area of 8. So this is a 1 out of 8 pieces. You know, that's where some of that, all of my work on the geo boards has been about what is this?
Right.
What is this thing?
And that's the hard part with the geoboard, because the numbers get confusing. You have 8 units that equal 1/3 of the whole, and that gets very confusing. But what's not surprising to me is the connection to money. That's an interesting thing. You don't have to teach decimals in order to get that connection. You just have to help kids think about how they know it. And Pema actually did that with, what's his partner's name?
Anita.
She broke it into a half, a 4th, and a whole brownie. And I said, well, what would you call all 3 parts? And Pema said 1 3/4. She had this look on her face. I said, well, she doesn't see that. Can you explain it? And his explanation was that the half was like 50 and the quarter was like 25, and therefore it's 75. She says, oh. So but then she still wasn't clear until he said, well, it's like having quarters and money. She got that. Then she made the leap back to the brownies. So this business of going back and forth between writing it as 3/4, seeing it as 1.75, or seeing it as 75 is not such a hard leap for kids. It's a question of us being comfortable with letting them know that these are different ways of thinking about something, and there are different ways of writing those ideas. But that 0.75 means the same as 3/4 in some cases. You know, so that part that you did here, although I wouldn't have put the dollar sign up. I would have left the dollar sign out because it's not really dollars that you're talking about. That was good that you did that. This whole business of what does the numerator and denominator mean, and what's staying the same. The conversation at that point is where you begin to see the inadequate or beginnings of understanding. What looks like understanding on the surface, when you dig a little bit deeper, it's very fragile. And for some kids, it's not even there yet. You have quite a range going on now, as always, right? when Lisa said, I add 1/4 and 1/4 and 1/4, and the numerators I'm adding, but the denominator stays the same, that's the kind of thing you have to listen for. Because that comment is what's going to push the development of the thinking about fractions. So I know it took us a little bit off where we were heading, but it was a big idea. Now, what's going to happen tomorrow is you're going to have different denominators. You're going to have a half
Right.
and a fourth. The
And
denominator doesn't stay the same
But
in
we've
that case.
investigated that to some degree, so what I'm going to be curious about is if anyone tries to add the half and the quarter, because they pretty quickly said, you know, you can't, this isn't a sixth. Because there was one question someone asked, well, why isn't that a sixth? And someone said, because look, it's a half. And then a quarter, that's huge. A sixth would be tiny. So they've already started talking, some of them have started talking about how the fraction has to be the same if you want to group them. And that's what uncover and cover up the two, you know those two fraction games that go with the fraction kits? Those both really reinforce that. You can only group like fractions.
Yes.
And why is that? Because, you know, they're the same.
So when you have that conversation tomorrow, you're going to have to watch to see how kids can prove that the half is the 2/4 and talk about how, in that instance, they turned both fractions into fourths. They made the denominator similar.
Right.
I wouldn't push for any of that, that's how you have to do it, but I would notice that that's what happened.
Wouldn't that be part of their way? How do you prove that a whole, a half, and a quarter is the same as 7/4?
Yes.
I mean, wouldn't someone say, well, let's try to put out all fourths and see that the whole has the 4/4?
You know, some kids over there at that front table, the kids on this side cut it into a whole, a half, and a quarter. The kids opposite them cut it into a whole and 3/4, a quarter, and a quarter. And they were starting to note, because Nancy was asking, well, how do you know, can you, they're the same, can you prove it? And it was kind of they were starting to put the pieces on top of each other. So that first table over there was starting to play with putting the fourths over the halves and seeing how they were the same. So you have a little group
Right.
over there that was.
And there was a couple of kids who were making the connection with the fraction kit. So that might be another way to prove it. Did you want to speak about anything in particular? Well, I think about, there was something else that came up.
No, as usual, it's just whenever there's a math congress, it's which part do I now focus on? And I think you jumping in and focusing on the numerator-denominator was an important relationship for them to get. You know, I always imagine, well, what if Lucy weren't here? Where would it have gone? You know?
Well, what would have happened is you probably would have gotten to the next solution, and that other conversation would have come out somewhere else along the
Right.
line. It's not like it had to happen there,
Right.
but you have to listen when kids are talking for those pieces that are going to get you that kind of conversation. Your 7/4,
And
where
does it
would
go?
it go on the
Right.
number line?
Right.
And make the number line more interactive, so that every time you're working with fractions, you're placing that number somewhere on the line. And you could write it in all three ways and
Right.
put it somewhere,
Right.
past the one, obviously, and see what happens. And Lisa, I'm like, whoa, she is this close to making a real generalization about people and brownies, right? So I changed the denominator on her, and she almost got that it would be 7/5. But then she said, no, you have to figure it out. So if you gave her two more problems, this kid would have that generalization. You know, that fraction would be there in a
Right.
second.
Yeah.
So I think you started in the right place.
Okay.
What do you think, and where will you go next?
I will definitely go to the next solution, which I think will bring up the idea of numerator and denominators again, and proving, are these the same, are these different, here's the whole, how does that work? There's a lot of conversation to come out of this, and different combinations of numbers as well. Once they start getting big ideas about the number of people versus the number of pieces, you know, the numerator-denominator relationship, to test that with different configurations of sharing, I think will bring out a lot, you know,
Right,
deepen
and
that.
deepen that.
Like, let's test those big ideas.
Yes.
And then another one, we haven't even come to the idea of 7/4 of what? Like, what's our whole?
Uh-huh.
You know, so you have 1 3/4 out of what? What, you know, what is that? that 7 brownies, so that issue of
That's
what is
tough.
the whole, that
That's
is
very
tough.
tough. That's
And
gonna
that,
be-
if we continue to do different configurations, will also get challenged and thought about. Okay, now we've got a 1 1/3 out of, those problems where they have the kids do different combinations and see who gets more.
Well, that's where you're looking for
yeah,
equivalence.
that's further down the line.
There was 2 places you could have gone. You went off with one, the way you had kids reflect back what they heard and pushed for the 7/4. But the 2 girls, when they said what they got, they said 1 3/4. So maybe when you start your conversation tomorrow, pick up here for a minute and say, they said that this was 1 3/4. Can someone prove that it's 1 3/4?
Okay.
Where's the 1 3/4 coming from? And then move to your next solution, which would be the one of 1 3/4.
Right, the whole
And then
1
move
3/4.
to 1 1/2 and 1/4.
Right.
And see that you can tie
Right.
it all together that way. And I think one more conversation will do you on this problem, and then I'd switch the numbers around.
I was
I thought they
really
did
pleased to
really
know
well.
that just about every child that I saw was dividing them up with no problem. Yeah, I watched LeVar. He said, "Oh, I'll cut them into halves. Then I'll cut them into fourths." And I went over, and he had a whole and 2 halves for everything. And I said, "How many brownies did you use?" And he was able to go 2, 4, 6, 8. Oops, too many. Like he was
Right.
able to realize with
Caught
those
his own error.
halves, like, okay, no, let me take away 2 of those halves. Now what are you going to do? And he cut the halves into quarters. Fairly
Catherine, I
quickly.
have to comment on how far the class has come.
Oh,
I
that's
mean,
good.
when we think about where they were, when if you saw this class in September, they could barely add. Conversation was not something they were good at. Listening to each other was a miracle. They have come an enormous way, and the techniques of having each child listen and respond back, it's just ingrained in the class now. They even respond to each other. If you listen to the language that the children are using, I disagree with this one, I support this idea. That is an amazing accomplishment. I think you should feel really good about that.
They sounded
gets to
really
take 'em
great.
on.
And I get to have them for another year, so I mean,
So
by
it
the
should
end
be
of that.
Spectacular then.
Yeah, they are. They
Accomplish
already
within
are.
next year.
And the way that they're making connections between and among the different things that you're doing is another good sign, because it shows that you have really taught them that it's all about thinking about things. It's all about making connections about things. And that's what good learning, especially in mathematics, is about. Because most of us learned mathematics in isolation. We didn't see how it was connected to anything, and we had no application for it. And we're not very good mathematicians as a result of it. But these children are breaking that mold, and that's great. It's like very exciting.
Good.
Do you want to say anything?
No, I noticed, I enjoyed hearing them talk about it and working it out with each other, and just, as you said, listening, the way they listen to each other, that is a wonderful skill that most of us have not been able to develop in our own children. And they're willing to share and do, and yeah, and just the thinking, the way they thought it all through, it's very clear. And they accepted each other's solutions, and they didn't say, "Oh, you're wrong," as you often hear.
And she's actually set that up in the meeting again. I'm sure it's been many times that when the little boy asked, what if I get the wrong answer, or whatever his question was, you said, so you'll change it, get another one.
Right.
Your
Your
classmates will help you,
Right.
those
Right.
kinds of things. Those kinds of comments build that community, that sense of community.
And it was so wonderful with you. I'm always amazed how comfortable, when you go into, as a visitor into a classroom, and the kids are comfortable with the visitors, and all the kids that I, approached, explained, "Oh, sure, I'll tell you," and it was wonderful that they could share their learning with the adults so easily. That was great too.
That's good. That's become the culture of this school. So, I've really tried to emphasize to them, you need to know what you're talking about so that when someone asks, it's actually, it motivates our learning because they know they're going to be asked. It's not one of these like fantasies, one day someone's going to ask you what you're learning in class. It happens every day. Someone's going to say, what are you working on? Explain it to me. I think it helps push them to be accountable for what they're learning.